you guys probably thought that I messed up my sign because I ran out of space, which maybe is partly true. But I also want to talk about this really big word here. This really big word is transformations. And it's got two parts, so let's break it down. Our first part up here in green is the word transform. And to transform means that we're going to change something. There's a lot of different ways that we can change things. We can change their size, we can change the shape, we can change the location. The second part down here says ations. And ations is actually a suffix that denotes an action. So if you think about the word exploration, that's the act of exploring something. So when we have this word transformations, that's the act of transforming something. In math, there are four main ways that we're going to transform geometric shapes. These four ways include translations, reflections, rotations, and dilations. When we're finished, your foldable is going to look something like this, where you can flip up each vocabulary term and see an example below. In order to complete the foldable today, you're going to need one of our papers that has the foldable on it. It might be yellow, it might be a different color, it doesn't really matter, just make sure that it is two-sided. You're also going to need some scissors and some type of writing utensil. Alright, so the first thing we're going to do in order to make this foldable is fold this paper in half. You're going to fold it in half on this line up here, and you want to have the vocabulary terms facing the front. Alright, once you've got it folded over, you'll notice that the top lines here are dotted. That means that we're going to cut on those ones. Only cut through the top layer. Do not cut through both or it will not work. Okay, so this is our foldable here. We have some notes on the inside that we're going to need to do. Alright, so up top here we have a translation. It says a translation is taking a figure and sliding it to a new location. So we're going to fill in the word sliding. Okay, and then it tells us down here that we need to translate the figure below down 2 units and right 3 units. So that's down 2 units and right 3 units. This is just another way it can be written. X coordinates go left and right. So we would be going right 3 or adding 3 to the value of whatever the original was. And then the Y value is telling us up and down, so that -2 would be moving it down 2 units. Okay, so we're going to do this down here. We're going to moving it down 2 into the right 3. I'm going to use some patty paper or tracing paper here just to help us get a visual. You don't need to do this part, but it can be a good strategy to use. So I'm first going to just draw in our X and Y axis so that we know where it started, and then I'm just simply going to trace over the triangle that we're moving. And I'm going to label our points A, B, and C. Alright, so that's where it's at. We need to move this triangle now down 2 units and to the right 3. So if I want to visualize where that's going to end up, moving it down 2, so here's 1, 2, to the right 3, 1, 2, 3. So it needs to end up there. You'll notice all of the points move the same distance. So when I take away this paper here, I'm just going to start at point A and I'm going to move it down 2 and to the right 3, and then I'm going to plot that new point. So A goes down 2 to the right 3, and A is right here. In order to keep the new point that I just plotted separate from the original, when I label this, I'm going to label it as A prime. That's how we denote the original figure versus the transformed figure. So A prime, it's just like a little apostrophe right above it that shows that it's the new point for A. And I'm going to do this to all the other points as well. Point B needs to go down 2 to the right 3. That becomes B prime, and C goes down 2 to the right 3. That becomes C prime. And because I was trying to translate the whole figure, I'm going to draw in the lines to connect the dots I just drew. And that's my new figure. So this figure has been translated down 2 and to the right 3. We have here a reflection is taking a figure and flipping it over a given line. I'm going to flip it over a given line. Okay, down here we're supposed to reflect the figure below over the y-axis. So a good thing to do first would probably be to identify our y-axis. Well, right here, this is our y-axis. And so we need to flip it, or we're thinking about like taking a mirror and mirroring it, reflecting it over that axis. So here's a visual again. Here's where it started. If I'm going to flip it over this line, that means that the y-axis needs to stay in the same spot, but I flip it. It should end up looking something like this, a little bit backwards of how it started. Right? So you'll also notice that when I did that, the distance away from the axis you're flipping over is the same. So here A started 2 units away, so it needs to be 2 units away on the opposite side. Again, we label it as A prime. C is also 2 units away, so it needs to be 2 units away on the other side, or C prime. And B is actually 0 units away from the line we're flipping it on, so B and B prime are going to be in the same location. And then we'll just connect our lines to form our triangle. And now we have reflected that figure over the y-axis. For our rotation, a rotation is simply turning a figure around a given point in a number of degrees. So you'll be given a point that you need to rotate something around, and you'll be told how far it needs to rotate. So down here we're told that we need to rotate the figure below 90 degrees counterclockwise about the origin. Okay, here's another way that it can be written, capital R, 90 degrees counterclockwise. Okay, so the origin is the spot where the two axes meet. So that's this spot right here. And we need to rotate this figure counterclockwise. Counterclockwise is the opposite direction that a clock moves. So it's going to go this direction. Right? So this is where our paper again comes in kind of handy. If I'm going to rotate it 90 degrees is a right angle. So that means that this axis here, my y-axis, needs to end up over on the x-axis. So I'm going to rotate, keep going until those meet up. That was 90 degrees here. We can see that A has moved down to here, C is now here, and B is actually in the same spot. So when I pick up this paper, I'm going to go ahead and draw those in and make sure to label them as primes. So B prime stayed in the same spot, A prime moved down to here, and C prime moved over here, and we'll just go ahead and connect them. Okay. So that was rotating this figure 90 degrees counterclockwise about the origin. All right, our last one is a dilation. And a dilation is enlarging or reducing an image by a scale factor of k. All right, well, these are two kind of large words in themselves, so let's break them down quick. Enlarging just means to increase or to make something bigger. Reducing is to decrease or make smaller. So if we're going to enlarge it, our original image is going to get larger. If we're reducing it, it's going to get smaller. And here our scale factor of k, that's just telling us how much bigger or smaller that shape is going to be getting. So we're supposed to dilate the figure below by a scale factor of 2. Here's another way that that can be written, D for dilation. 2 would be the scale factor, and so each of the coordinates is just going to end up being multiplied by that value. Okay, so down here below, we're going to dilate it according to our origin here. So from our origin to get to A, we had to move up 1, 2, and over to the left 2. If we're going to dilate it by a scale factor of 2, they're going to increase by that factor of 2. So now instead of moving up 2 and left 2, we're going to move up 4 and left 4 because 2 times 2 is equal to 4. So that was to get to A. That makes it A prime. We do the same thing to C. For C, I had to move left 2, and so to multiply that by 2 makes 4. So I need to move left 4, and I didn't move up or down at all. So it's actually going to stay in that line. That becomes C prime. And the B is actually going to stay in the same spot because it moved 0. It's at the point 0, 0, and 0 times 2 is 0. So B prime is going to be in the same spot. When I connect those lines here, you'll see that this triangle is actually quite a bit bigger. It's twice as big as our original triangle because we did multiply it by a scale factor of 2. Alright, as a final review for today, a transformation again is the act of transforming or the act of moving a shape. So for today we covered 4 different types of transformations. They were translations, reflections, rotations, and dilations. Make sure you study those, practice them a little bit, and hang on to this foldable because you can use it for the test.